Now we will move into another critical area of battery safety, that are the thermal and mechanical hazards. And here specifically we will focus on the thermal runaway. This is one of the most dangerous risks in battery systems, and especially in high voltage environments, for instance, like the electric vehicles. So let's start explaining what the thermal runaway is. So this is a phenomenon in which there is a self-sustained chain reactions where the temperature in our battery will increase uncontrollably, and this creates a domino effect that at the end can lead to fires and explosions in our battery. The thermal runaway process starts with one of the cells that rise in temperature, and in these cells, as the temperature increases, the chemical reactions inside of this battery accelerates. The acceleration of all of those reactions will create a self-reinforcement cycles for raising the temperature even further. The heat that is being generated inside of these systems cannot be dissipated anymore at a certain point, and this will result in a rapid buildup of the temperature within the cells, and finally it will cause also the propagation of the thermal runaway to adjacent batteries in our system, battery cells in our system. At some point, the cooling systems and any method that we may have to control the temperature will become inefficient, and this will lead to critical safety situations, like for instance fire hazard, explosions, toxic and flammable gases that gets released from the battery, damage of equipment, also environmental damage, dangers and safety risk for the persons, and also the system shut down. To protect lives in the case of battery failures, there is this rule, that is the 5 minutes rule that has been proposed. This is a rule that basically requires that in any event where there is even a severe crash, or when we have a triggering incident in our battery system, the battery must not pose a serious risk of fire or explosion for at least 5 minutes after the incident. And this time provides a very crucial window of time for the driver or the passengers of the car to evacuate safely before there is the risk of explosion and fire. In this case, safety features like, for instance, thermal barriers and cooling systems, as well as the overall design of our vehicle and the pack of the design of our battery pack, will work together to delay the thermal runaway as long as possible. As you can see here, this is one rule that was recently integrated in the ECE R100, and this is one regulation that has been developed to standardize the safety measures for electric vehicles and hybrid vehicles. And basically it applies to the design of the battery, the construction of the system, of the full vehicle, and the performance of these high voltage systems, and it ensures the safe operation under several conditions. Now let's take a closer look at the different paths that the thermal runaway may have in electric vehicles and in the batteries in the electrical vehicles. So in these slides we illustrate how various internal and external factors can trigger the thermal runaway, and also it stages what happens at each stage in this process, and this helps us to understand why it's important for designing systems and how to design those systems to prevent such events. So let's break it down, and let's break down all of these stages, also categorizing by the process that take place into, and split it like in the mechanical damage, electrical damage, or the thermal influence in these events. And let's start then with the mechanical events that might initiate the thermal runaway process. We have in this case, for instance, impact of our system that can be, for instance, a collision or a drop of the battery. And this type of impacts can physically deform the battery cells and damage the internal structure of the cells. Another type of mechanical damage that we may have is, for instance, caused by vibrations or by shock. When we exposed our system to prolonged mechanical stress, this will make our system to be more susceptible to failure, because the materials will weaken over time. And another type of mechanical factor that can affect, for instance, is the penetration. And the penetration is, for instance, having sharp objects or having sharp tools accidentally piercing the cells, and this will create as well damage in the mechanical structure of the battery. In all of these cases, the structural integrity is compromised, and accordingly it can create internal short circuits that will cause an electrical failure in the system. Now let's see what are the different electrical problems that we can have in our batteries. We can see that basically any of the electrical hazards that we can have will accelerate the thermal runaway process. One of those electrical hazards are, for instance, external short circuit, as well as the internal short circuits that are caused by mechanical damage. We can also have overcharging or over discharging, and at the end all of these electrical events will disrupt the normal electrical operation of the battery and will generate an excessive amount of heat that at the end will trigger the thermal reaction. And finally, we have then the thermal stress that can both trigger this reaction, but also it is a consequence of all of the previous events. In this case, for instance, some of the factors that can influence the thermal runaway are, for instance, to expose our battery to thermal stress and to have poor thermal management that at the end cause the cells to go beyond the safe limits of those cells. Also, we have here stated once the battery cell is exposed to temperatures that are above 130 degrees, the separator, that is the element inside of the battery cell that separates the anode from the cathode, this element will melt, and it will release a high amount of flammable gases, and at the end will cause as well the acceleration of the thermal runaway. And because of all of this, at the end we will have the thermal runaway. And as it was explained, according to the 5 minutes rule, all of these events have to be controlled and have to be held back for at least 5 minutes before having the possible explosion or the possible release of electrolyte gases and after venting the cells and so on. Now let's see how the battery design and how manufacturing the batteries can be our or one of the first barriers that we have as prevention for all of these hazards. The battery safety will start with thoughtful designs and also precise manufacturing processes. In the design of our batteries, for instance, using high quality materials like, for instance, ceramic coated separators or any other type of thermal isolations of high quality, will add layers of protections by delaying the transfer of heat and delaying as well the thermal runaway. Also, in all of this, the design of the cells plays a crucial role, because when we are choosing thermally stable chemistries, we can prevent this type of events. And as well, alongside with this, having effective thermal management systems is essential. We have different types of thermal management system. We have, for instance, liquid cooling, heat sinks. We have cooling plates that can be placed in our battery to be able to dissipate the heat before all of this escalates into a dangerous situation. And finally, on top of that, I think that innovative structures that are proposed, for instance, this is one of those innovative structures, that is a cell-to-chassis integration that allow us to absorb impact energy and reduce the risk of mechanical damage during collisions, are some of the other approaches that we need to integrate in our design and manufacturing processes. And talking about manufacturing processes, the precision on those processes is as important as the design and the material that we will employ. Processes that ensure that we have, for instance, uniform electrocoating in our cells, as well as alignments in the different layers of our cell production, ensures that the cells will have less probability of defaults, and this of course will means that we will have safer battery cells, that at the end also means that we will have safer vehicles in general. The rigorosity that we have in the quality control at every stage of the production will ensure that the cells, the modules, the packs, and the full vehicle meets the safety standards and are aligned with the needs of this industry. Another essential component that will prevent the thermal hazards is the battery management system. The battery management system basically is the system that continuously monitors the state of the battery, and also it's capable of identifying potential risks and ensuring the safety of the system. Some of the features that the BMS has is, for instance, it prevents overcharging or over-discharging the battery, and this is possible by means of measuring continuously the voltage of all of the cells in our battery. Also, the BMS monitors the temperature across the battery pack, and in case of any of the cells begins to overheat, the system can activate cooling mechanisms or to disable the battery, shuts down the system, and to prevent escalation of all of these events. And also the BMS is capable of detecting faults like short circuit, for instance, and in the case of a short circuit, the BMS reacts fast enough to prevent them to progressing into larger issues, like for instance delivering a large amount of energy of the battery and provoking the overheating and at the end the thermal runaway. And the last one of the features of the BMS is the communication, and this communication happens between the battery and the vehicle or any other supporting system, and this provides real-time data of what is the health status of the battery, and with that information we can take proactive responses to any potential risk that we can detect with a lot of time in advance. When we are dealing with thermal hazards, it is very important to consider and to know what will happen in case of a fire, and for knowing how to react in case of a fire. This process over here is one standard that will provide us all the procedures for the first responders and also to know how to handle such incidents. These are the initial steps that are described in the standards. And here basically we see that I will describe each of the steps, and the first one basically is to have an assessment of what is happening in the scene. In this case, once we detect that there is a thermal hazard, the first responders have to evaluate the situation and also evaluate the different hazards, and to identify those potential hazards that might be, for instance, fire, chemical leaks, or electrical risk, to be able to determine how to react. Based on that, they have to take a decision whether they will have an active or a passive response to that. In the case that we have a passive approach, we will it means that after doing the assessment of the scene, we determine that we will only monitor the situation and there is no any immediate threat, because I don't know, maybe there are not occupants around it, and there is not a big risk of fire, or there is no risk of taking proactive measurements at this time. On the other side, if it is required, then we can also take an active approach, and basically here the goal will be to suppress the fires or to cool down the battery when the situation demands to have this immediate action. And one of the first response that we may have, and that the certified people can act on that, is to have the occupants rescue. If there are passengers, for instance, trapped inside of the vehicles, the responder prioritize access for those occupants before continuing any firefighting efforts. Once we have rescued the different passengers and they are they are secured, then the firefighting actions start. And for instance, in this case, the high voltage system is insulated and the fire is controlled using the appropriate methods. In order to use the appropriate method for controlling the fire, we need to know what are the different sources of fire and also what are the different extinguishers that we can use, because it's very important having the correct extinguishing method that is aligned to the source of the fire. Using the wrong extinguisher, for instance, can be very dangerous. If, for example, we use a class A extinguisher in a gasoline fire, that can even spread the flames further and be worse, and the solution be worse than the actual problem. So here, let's review the different types of extinguisher that we can have. First, we have here the class ABC extinguishers, and these basically are designed for fires that are involving any ordinary combustible like wood, plastic, flammable liquids like, for instance, gasoline, and also it is meant to be used in electrical fires. These are very versatile and they could be used in lithium-ion batteries, but they are not sufficient to control a lithium-ion battery fire. On the other side, we have the class BC extinguisher, and this is specifically targeted for flammable liquids as well as electrical fires. And finally, we have the water, and the water is one of the best approaches that we can have for battery fires. In those cases, we use a large amount of water with the purpose of cooling down the battery and prevent further thermal runaway, as well as reduce the risk of reignition in our battery system because of this thermal runaway expanding in all our battery cells. To conclude with this thermal hazard section here, and also to conclude with this mechanical hazards section. Here we wanted to show you how maybe vehicle manufacturer like Hyundai has addressed all of these risks through safety features that they include in the electric vehicle battery systems. First, we have the different approaches that they have for the mechanical hazard. Hyundai proposed a very robust construction techniques that at the end minimize the damage during collisions. For instance, their battery, they have rigid cell architectures, and within this battery architecture, they include, for instance, impact absorbers, and all of that creates a lot more resistance to collisions in the vehicle. Also, the cells they are designed using ceramic coated separators, and this improve as well the strength of each of the cells in our battery. Regarding the thermal management, in this case, Hyundai incorporates pouch type lithium-ion cells, and these particular cells are very good with the heat dissipation, and that help us to control then the propagation of temperature along our battery. As well, they also use materials that have very high heat dissipation properties to manage at the end the high temperatures effectively, and to help to stabilize temperature in our systems. Regarding the electrical safety and the electrical measurements that they have, Hyundai employs a combination between active and manual protections. All of these in looking to safeguard the electrical hazards that may, for instance, at the end cause thermal hazards. In the active protections, as was mentioned, they have, of course, a battery management system that will monitor and that will control all of the possible faults that the system may have, as well as will shut down the system if any issue is detected. There are also some manual protections, for instance, circuit breakers or fuses that are designed to reduce the risk of electrical overloads. And I will say that on top of that, all of this is carefully tested, and they have a different type of battery testing, for instance, crash, an impact test, water tightness, submersion of the batteries, combustion, so to expose the battery to direct fires, and to guarantee that in all of those conditions the vehicle is performing in a safety way. And finally, let's present the chemical hazards that we may have in our vehicles. When we refer to the chemical hazards, this basically will arise from all of the materials that are used in our batteries and in the vehicles. And finally, all the exposure of those materials that can pose serious risk for the people and for the environment. These are some of the types of toxic active materials that are inside of the battery cells, and that can pose severe exposure to toxic chemicals. So let's start with the materials that are in the active materials. We have in the cathodes and in the anodes usually for instance, cobalt, nickel, and manganese, and all of these might be toxic and harmful for the human health in general. Also, we have solvents in the electrolytes, and these solvents can release vapors and also irritate the respiratory systems, as well as to cause long-term health effects if we breathe those vapors. And finally, we also have the electrolytes, and the electrolytes contains compounds like the lithium hexafluorophosphate, And when this is exposed to moisture, for instance, this creates this hydrofluoric acid that is very dangerous also for human beings, because at the end this is a highly corrosive substance. When the batteries are damaged, they are overheated or they are mishandled, they will release some of these harmful gases and also harmful vapors into the air. Some of that, of course, will cause, for instance, we will inhalate all of those, and they pose severe problems to our respiratory system, as well as will cause some long-term effects. Inhaling these gases can irritate our respiratory tract, and in severe cases can lead to long-term lung damage and to have acute poisoning in some of the cases, and depending also on the duration of the exposure that we have to those. As well, we will get in contact with flammable gases, like for instance hydrogen gas, which can, besides of the toxicity, it can create the danger of having an explosion, and also that is very dangerous specifically when we don't have adequate ventilation. And finally, let's review here quickly what are the preventive measures that we can take in case of chemical hazards. So the first one is to use the appropriate personal protective equipment, and in this case this includes, if you are, for instance, working in a production of battery cells, you should wear respiratory protection depending on the process where you are working on, to always use gloves and protections of clothing, eye protections, footwear protections as well. We have also to ensure that all chemicals are stored properly and handled properly, and also to ensure that the workspace has proper ventilation and emergency response systems. For instance, air quality monitoring, fire suppression systems, emergency response plans, and ventilation systems that will help us to respond in case of any chemical hazard.